So in this lesson, we focus our attention on fundamental theorem of calculus. Okay, so basically our goal is to evaluate a definite integral, interpret an area below the horizontal axis, and solve some applied problem. So fundamental theorem of calculus, there are two parts. Fundamental theorem of calculus, I call it FTC from now onwards in short, okay? Part 1 and part 2. So I want to begin with part 2 first, and we'll do part 1 later, okay? So fundamental theorem of calculus part 2 says that if f be any continuous function over the interval ab, and f, you see this one is a small letter f, and this one is a capital letter F. So a small letter f be any continuous function over the interval ab, and this capital letter F be any antiderivative of f. See that? Okay, this capital F is the antiderivative of small letter f. Then the definite integral of f from a to b equals f of x from a to b. Okay, see that f is the antiderivative, integration of the small f. So what it means is f of b minus f of a. And this, if you just solve a little bit, this equation can be solved a little bit further. So we got that a to b f of x dx equals f of b minus f of a. So if you want to write f of b, just simplify it, and you're going to get f of a plus a to b f of x dx. If you just simplify using high school algebra, you can get this one. So the fundamental theorem of calculus part 2 is this formula. Please remember. And you need to know some properties of definite integral as well. Okay, some of the properties of definite integral, we know that definite integral represents the area. So if I ask you area from a to a f of x dx, that is obviously 0, right? Suppose you have a function, okay, and this is your a, f of x. If I ask you what is the area from f of a to a, of course it is 0. A to b k f of x can be written as k integration a to b f of x dx. If we have sum, addition and subtraction, we can actually separate like this. One important thing is that a to b f of x dx can be written a to c f of x dx plus c to b f of x dx. So for example, what this means is, suppose you have a function, okay, this is your f of x, and a, this is your 0, a to b. So when we say a to b, integration so this represent a to b f of x dx. So we know that definite integral represent the area. Now suppose c is here, okay, suppose c is here. So can I write this one equals a to c f of x dx, means this part of the area, and plus c to b f of x dx means this right side of the area, right? So this represent, this means this part, this means this part. So we can split that way. That's what this property tells us, okay? And a to b f of x, if you change, if you switch the limit, then the sign will change. Okay, here notice that this one is a to b, integration a to b f of x dx equals, if you change the reverse the order b to a, then the sign will change. Just keep that in mind. Let's look at example 1 quickly. Consider a function f of x equals 1 plus x on the interval 1, 3. Find the area under the function f of x by two methods, using the geometry and using the fundamental theorem of integral calculus. Okay, so this is kind of review from our previous lesson, but let's look at part A first. Draw the graph of that function. So if you draw the graph, then this is 1 plus x. So this is your 1. So the graph will look like this one. And so we want to find area from 1 to 3. So 1 is here and 2 is there, 3 is there. This is your function f of x. So basically we want to find this area using geometry. And you know how to find it. I think we have already done similar questions earlier in the previous section. Okay, so area is half f of 1 plus f of 3 times this distance is 2. So half f of 1 is what? F of 1 will be 2 plus f of 3 is 4 times 2. So this 2 to cancel out, so you're going to get 6. Part B, using fundamental theorem of calculus. Okay, what it means is area equals, we know that definite integral gives us the area f of x dx. So a means 1, b means 3, function is 1 plus x dx. And so find the antiderivative of this, which will be antiderivative of 1 is x plus antiderivative of x using the power rule, x squared over 2 and 1 to 3. So you're going to get 3 plus 3 squared over 2. Okay, substitute x equals 3 first, minus, as you know, first you put the upper limit and now you put the lower limit. So lower limit means x equals 1. So it will be 1 plus 1 squared over 2. So if you simplify, you should be getting 6. Okay, so this is what the fundamental theorem of calculus is, part 2. Now let's try a few more questions. I will do 2 of these. There are 1, 2, 3, 4, 5. So tell me which one you want me to do. I will do 2 of them for you. Okay, it doesn't matter, right? Any 2 would work. Okay, so let me do part B maybe. So part B, 0 to 8. This is x raised to power 1 over 3 dx. So that means using the antiderivative, it will be x 1 over 3 plus 1 divided by 1 over 3 plus 1. And because this is definite integral, don't put the c. There is no constant of integration for definite integral. And it will be from 0 to 8. So this will be x raised to power 2 over 3. And this is 1 over 3 plus 1 will be 4 over 3. Sorry, this is 4 over 3. And x divided by 4 over 3, 0 to 8. So that's going to give me x 4 over 3. If you flip it, you're going to get 3 over 4. And then this will be 0 to 8. So 3 over 4. So you'll get 8 4 over 3 minus 0 4 over 3. So the answer would be, I believe, 12. That's it. This is fundamental theorem of calculus. Let's try E. So part E is 1 to E 1 plus 2x minus 1 over x dx. So this means first you find the antiderivative of this function, which is x plus 2x squared over 2. I trust that everybody know how to find the antiderivative, minus ln x 1 to e. Okay, all you need to do is substitute the value. So you're gonna get, put the upper limit first. So e minus 2 to cancel out, you'll write, sorry, plus e squared minus ln e, by putting e there for x, minus, now we substitute 1 for x, which is 1 plus 1 squared minus ln 1. So if I simplify it, I'll get e plus e squared minus ln e is 1. I believe everybody know this. Okay, minus this 1 plus 1 actually is 2, minus 2 minus ln 1 is 0. Okay, ln, recall from high school, ln e is 1, ln 1 equal to 0. It's natural logarithm, so recall that. So your answer, final answer, is going to be e plus e squared minus 3. Okay, I trust that you can do the other by yourself. So example 3. This is the application of fundamental theorem of calculus part 2 in business situations. Okay, suppose that y is the profit per mile traveled and y gives us the profit per mile traveled, and x represent the number of miles traveled in thousands. So find the area under y equals 1 over x over the interval 1 and 4 and interpret the significance of this area. So interpret the meaning of that area. Okay, that's what the question is asking us to do. Now, first of all, if I draw the graph of this function, let's draw the graph of this function. So the graph will be 1 over x. So that means the same graph like we done in our previous lesson. So 1 to 4. So 1 is here and 4 is here, let's say. So we're talking about this area. So how do we find the area? Well, you already know, right? So area is given by the definite integral a to b f of x dx. So which means a is 1, b is 4, our function is 1 over x dx. And we know that 1 over x dx is actually ln x from 1 to 4. So this gives us ln 4 minus ln 1, which is ln 4 is, you have a calculator, I believe it is 1.3863. That's what my calculator gives me. Minus ln 1 is 0. So basically you got 1.3863. That's what we got. What it means is this represents the profit. Okay, so the meaning here is the profit is, interpretation means meaning. the profit equals $1.3863. Remember, this is in thousands, so this thousands. When miles travel, when traveling distance is traveled distance is from 1,000 miles, because everything in thousand, from 1,000 to 4,000 miles. Okay, so that's the meaning. Done. Now let's look at example 4. Do you have any question for example 3? All right, so let's look at example 4 now. So let f of x equals p prime of x equals 4 minus x squared. And what we want to do here is, if f of x represent the marginal profit function, you see f prime of x, the derivative of profit function, is given there. So which means marginal profit is given in millions of dollars of a company, and x represent time in years. What is the total profit in the first 3 years? So in part A, we need to find total profit in the first 3 years. In the first 3 years. So that means from 0 to 3 years, right? That's what it means. So basically the total profit is given by I just write P there, antiderivative of the derivative function from 0 to 3, which is 0 to 3. P prime of x is already given 4 minus x squared dx. And now I want you to complete this. What is the profit, total profit? So if you, using the fundamental theorem of calculus, first find the antiderivative, which is x cubed over 3, and it is 0 to 3. So that's going to give me 4 times 3 minus 3 cubed over 3 minus 0. So that is 3. Yes, 3, because the unit is in million, so it is $3 million. Right? So that's the profit. Now, in part B, find the total area enclosed by the function f of x and x-axis from x equal to 0 to x equals to 3. Okay, now in this case, what we want to do is, we will see, we are talking about area now, pure area. So area means it cannot be negative. So in part B, in order for this, we first draw the graph. Okay, so to find total area, first draw the graph. Let's look at the graph. If I draw the graph, then the graph looks like, okay, the function is 4 minus x squared. I trust that everybody know how to draw the graph of that function. Let's say 4 is there. It's a parabola opening down. Okay, so this is my function f of x, which is 4 minus x squared. So that's the function. Now we are talking about, and notice that this graph will cross the x-axis at, what are these 2 points? So can you find that out? So point of intersection is 4 minus x squared equal to 0. So that means x equals plus minus 2. So basically this graph cross the x-axis at 2 and negative 2. Okay, so we need to find area from 0 to 3. So that means 0 is there. 0 to 3 means we need to find this area plus 3 is there. Okay, 3 is there. So we need to find that area as well. This area. Okay, notice that this green part is actually below x-axis, so it is actually the negative area. But since if we are talking about the geometrical figure, pure geometrical figure, then area cannot be negative. So in that case, what we need to do is total area is given by, we know that it is from 0 to 2 f of x dx plus 2 to 3 f of x dx. Since this is below x-axis, so this value will be negative, we need to make it positive. Take the absolute value sign. That's all we need when we are talking about pure area. So this one is 0 to 2, which means 4 minus x squared dx plus absolute value 2 to 3, 4 minus x squared dx. So I trust that you guys know how to evaluate this integral. So it's gonna give you 4x minus x cubed over 3, 0 to 2 plus absolute value sign 4x minus x cubed over 3, 2 to 3, and let me know what you get. So anyway, I trust you will be able to calculate this. And so here the first part will be 16 and second part will be, I believe, 7 over 3. That's what I got. Make sure that my calculation is correct. If my calculation is wrong, let me know. So that's going to give me 16 plus 7 over 3, so which is 16 over 3, sorry. So which is 23 over 3. So that's what I got. That is the total area. Okay. Now, example 5, it is very similar to example 3, and I think you can do this by yourself. In example 5, what we are supposed to do is an airline determines that the marginal profit resulting from the sale of X seats on a jet traveling from city A to city B in hundreds of dollars is given by, okay, the marginal profit is given. So we need to find the total profit when 60 seats are sold. So basically, you need to find the profit from the first seat, from the second seat, from third seat, so all the way from up to 60, right? So basically the total profit here will be from 0 to 60, this one. So basically 0 to 60 and square root x minus 6 dx. I leave it to you and you complete that by yourself. And now the last questions for fundamental theorem of calculus part 2. So the last question, and part 1 will do that later. Okay, let's first finish this all the examples with fundamental theorem of calculus part 2. Okay, so in example 6, suppose f of t has the derivative f of t. Again, The derivative of f of t is small f of t. This capital F of t has the derivative of small f of t shown below. And suppose that we know f of 0 equals 5. Find the value of f of 1, f of 2, all the capital F1, capital F2, capital F3, capital F4. Now recall the fundamental theorem of calculus. So the fundamental theorem of calculus is, we know FTC is a to b f of x dx equals f of b minus f of a. We know this. Now we also know that f of b, using high school algebra, just simplify and you're going to get f of b equals f of a plus a to b f of x dx. So we know this. Now looking at from the second perspective, let's see what we will have. Let me just copy this. We know FTC is f of b equals f of a plus a to b f of x dx. We know that. So now if I want to calculate f of 1, for example, 1 means right there. So let me substitute b equals 1. So when b equals 1 and a equals 0, then this one will be f of 1 equals f of 0 plus a is 0 to 1 f of x dx, right? So we already know f of 0, it is already given. F of 0 is 5 plus 0 to 1 f of x dx is actually the area. This area, this is actually the triangle, right? It's the area of triangle. Area of triangle, which is 5 plus. So that small area of triangle you can calculate by using the geometry. So half base times height. So half base here is just 1 times height is also 1. So you got how much is that? 5.5. Okay, f of 1 we got. In the same manner, let us calculate f of 2. So f of 2 will be, in this case now, f of 0 plus 0 to 2 f of x dx. So f of 0 is 5 plus 0 to 2 means now we are talking about this area, 0 to 2. Again, this is another bigger triangle than before, right? So we're talking about this area. So we have area is half, base now is 2 times height is 1. So we got 6. In the same manner, you can calculate f of 3, which is f of 0 plus 0 to 3 f of x dx. And I leave it to you. Okay, you just calculate this triangle plus this triangle. So let's complete this quickly just for fun. So 5 plus half. When we are talking about pure geometrical area, then yeah, anyway, complete it and by yourself, and if there is any question or issue, then we'll talk about it in our next class. And in the same manner, I trust that you can calculate f of 4. So fundamental theorem of calculus part 2, we are done. All right, and we'll do this fundamental theorem of calculus part 1 later. We'll complete that later.